Hello students. So today we are going to discuss board exam questions 2026 from chapter 1. Already we done the MCQs, 1 mark problems from the board questions from the chapter 1. Already part 1 video over. This is part 2 video. So in this video we will discuss some 2 mark and 3 mark questions. In 2 mark, the first question is the HCF of 210 and 55 is expressed as 210 multiple 5 plus 55m. Then find the value of m. So HCF of these two numbers can be expressed in the form of this. Then what is m? That is the question. Okay. So first find the HCF of these two given numbers. To find the HCF, first find the prime factors of the given numbers. First number is 210. So 210 can be divided by 105. Now 105 can be divided by 5 table 21. Now 21 can be divided by 3 table 7. Next find the prime factors of 55. Now 55 can be divided by 5 table 11. So 11 is the prime number. Okay. Now 210 we can express as 2 multiple 3 multiple 5 multiple 7. 55 can be expressed as 5 multiple 11. So we should find the HCF because it's given the question. Okay. So HCF of these two numbers 210 and 55. To find HCF, we should choose common factors with smallest powers. So what are the common factors here? See this 5, 5. So only we have 5 is the common factor. So write the common factor 5. The least power of 5 is 1. So 5 is the HCF of these two numbers. Now that HCF can be expressed in this format. It's given the question, which means this HCF value should be equal to this one. Equate these two, we can find the value of m. So 210 multiple 5 plus 55m, which is equal to 5 because 5 is our HCF value. Now just simplify this. What is 210 into 5? Multiple of these two is 1050 plus 55m equal to 5. Okay. Now shift this term into this side. So 55m is equal to 5 minus 1050. So 55m, which is equal to 5 minus 1050 is minus 1045. Now m, which is equal to minus 1045 divided by 55 because the left side 55 in multiple operation, shift this 55 into right side and it's a division. Okay. Now which is m equal to minus because numerator is negative, denominator is positive. So division of these two should be negative. So m, which is equal to, it's exactly 19 times. So if you divide these two now, it's exactly 19 times. Okay, we will check. We will check this. So 1045 divided by 55. So 155 is a 55. So remainder is 49. Down the next number is a 5. So this is exactly multiples of 9. So 5 into 9 is 45. 5, 4 carry. 5 into 9 is 45. 45 plus 4 is 49. So remainder is 0. So exactly 19 times. So the value of m is minus 19. The next problem is prove that root 3 is an irrational number. So we can prove the number root 3 is irrational by using the contradiction method. So we will start with our assumption. Actually we have to prove root 3 is irrational, but we assumed root 3 is irrational because we are going to prove the statement by using only the contradiction method. So first assume root 3 is rational. So we assumed root 3 is rational. We know the definition of rational. Rational number can be expressed as in the form of p by q, where pq not equal to 0 and p and q are integers. correct? So similarly, we can express root 3 as root 3 equal to a by b, where b not equal to 0 and a and b are co-prime integers. Now squaring on both sides, so root 3 the whole square is equal to a by b the whole square. So square of root 3 is 3, square of a is a square, square of b is b square. Now shift this divided b square to this side, so 3b square is equal to a square. Consider this statement as equation number 1 because we will use this equation. Okay, now shift this multiple 3 into this side, so b square is equal to a square by 3. Now we got the statement 3 divides a square, but 3 is a prime number. If a prime number p divides a square, then p is also divides a square, a. Okay, now the prime number p divides a square, so from the theory we can write 3 divides a also. Okay, now 3 divides a. The meaning of the statement is when a divided by 3, you will get some quotient. So let a by 3 is equal to c. Consider when a divided by 3 it is equal to c. C is a quotient. Okay, now squaring on both sides, so a by 3 the whole square is equal to c square. Now square this value, so a square divided by 9 is equal to c square. Now from the first equation, what is our first equation? This is our first equation. So in the first equation, a square is 3b square. Now we can substitute the a square here. So instead of a square, we can substitute 3b square by 9 is equal to c square by using equation number 1. Now we can cancel these two. 1 3s are 3, 3 3s are 9. So we got a statement b square by 3 is equal to c square. So meaning of the statement is 3 divides b square. 3 divides b square. By using the same theory, yes, instead of a we have b square. Okay, so now by using the same theory, we can write 3 divides b also. Okay, now we got the statements 3 divides a and also 3 divides b. The meaning of this is 3 divides a and b also. So 3 divides a and b. But we know about a and b. See this. Actually a and b are co-prime integers. What is the meaning of co-prime? The co-prime, two numbers are co-prime, meaning is HCF of those two numbers should be equal to 1. So HCF meaning is highest common factor. So if two numbers are co-prime, then highest common factor should be 1, which means other than 1 we have no common factors for those two numbers. Now we got a statement 3 divides a and b. The meaning of the statement is a and b have common factor, that is 3. Okay, so the statement is contradiction to the statement a and b are co-prime integers. So this is the contradiction to a and b are co-prime integers. Why it has happened? We got the contradiction statement. Okay, wow. So why it has happened? Because of our assumption. So what is our assumption? We assumed root 3 is rational. Because of our assumption only, we got the contradiction statement. Okay, we assumed root 3 is rational. From the rational only, we express root 3 as a by b, and where a and b are co-prime integers. But finally we got the statement a and b have a common factor, a and b have common factor 3. But that is contradiction to a and b are co-prime integers. It has happened because of our assumption. So our assumption is wrong. Our assumption root 3 is rational is wrong. So finally we can conclude root 3 is irrational. So finally we proved root 3 is irrational. So we proved the statement by using the contradiction method only. Okay. Now the next problem is prove that root 2 is an irrational number. So previously we proved root 3 is irrational. The same idea, instead of root 3 we have root 2. So by using the same idea we can prove this problem. So by using the same idea of the previous problem, we proved root 2 is irrational. Same proof, that's why I skipped the part of that video. Okay, same proof. How we proved root 3 is irrational. By using the same idea, we proved root 2 is irrational. Okay, by using the contradiction idea. Okay, so now we will solve the upcoming problems in the next video. This is part 2 video. Already we completed part 1 video. Okay, so we will continue the following problems in the upcoming video. It's a part 3. Okay, thank you students.